The next question reads as follows. It says to us, below is a table depicting the total number of South African road fatalities. Oh, wow. Accidents all the way. Okay, so people who died from 2012 to 2016. So these all happened on the road. It's people who died on the road. We've got our data happening over there. And it says to us, illustrate this information in a bar graph on the axis given below. So what we need to know about bar graphs. So we've been given that bar graph. And if you have been watching all the revision sessions, you will be aware of all the rules I've been saying to you guys, and just me saying to you guys, please know the different types of graphs that are given to you. Do not cram one graph and then think this is the graph that's going to come out or whatever. You could either be asked to draw the graph, or you could either be asked to interpret the graph. Stunning. So in this particular case, we are being asked to draw a bar graph. The first thing you do need to know when you are drawing graphs, number one, you need a title, a suitable title for the graph. So be super careful in terms of giving your title, okay? So your title needs to be according to what you have been given. The second thing that you need to give are your axes. The axis, you need to label your axis. So you need to label your vertical and your horizontal and your vertical axis. Please be super careful with that as well, because some people take the two axes and then they swap them around and then the graph becomes completely wrong. The next thing you need to know are the rules that concern the graphs. Bar graphs have bars which are the same in width. So they have to be the same in terms of how wide they are, and the spaces in between also need to be equal in length. Let's see if we can kill this particular bar graph that we have been given. The horizontal axis is going to be your independent, okay? Independent means that it's going to happen either way. Dependent means that it depends on the independent. In this particular case, time would be our independent, and normally time is an independent. Why is time independent? Because time happens whether we are doing anything or not. So whether there's a fatality or not, whether people are going to die or not, time is still going to move. Whether you are watching the show or not, time still moves. So time becomes our independent variable. So in this case, it means that the years are going to be our independent, and then the number of deaths are going to be our dependent. Let's go and put it in and see what it looks like. So the first thing that we need to do is give our graph titles. You get marks even before you start plotting your graph. How much is this out of? 9. Okay? So the first thing I do is give my graph a title. Below is a timetable depicting the total number of South African road fatalities. So we need to write there total number of South African road fatalities from 2000 and whatever to 2016. So I can say number of fatalities. Let's say total. It's important what you write in this particular place. So I can say total number of deaths. Total number of deaths, or total number of South African deaths. Total number of deaths in SA. Okay. So we can have that from 2012 to 2016. So that is in terms of fatalities. No. That is in terms of, fatalities. Guys, it's very important that you write the right thing here. Fatalities. I think I wrote that correctly. Perfect. So now I've got the title of the graph. I get a mark for that. I've got 1 out of 9 even before I move anyway, okay? So here I can say years. I'm writing it underneath so that I can be able to still write on top there. And then here, number of fatalities. I already now have 3 marks, guys. I have a mark there and I have a mark there. So I always say, don't miss the 3 marks. Those are like, they're not free, but they're sort of free, okay? The next thing I need to do is find a suitable scale. Suitable scale to put in these numbers. These are nice, they're in order, so I don't need to struggle with my x-axis. So I'm going to put in 2012, 14, 13, and so on. So let's go down and put that in. So years. The first thing that we said about our bar graph, it must not touch. It cannot touch this, okay? So your bar graph should not touch over there. Nice one. So 2012, I'm just going to say 12, 13, 14, 15, 16. Let's just write that 2000 because we don't want to get confused. Okay? Another mark for that. That's, guys, marks. I'm going to put a mark there so you know what I'm talking about. The next thing is one of the most challenging things that learners find, and that's finding a suitable scale for a number like this. How I would choose to write something like this, I would maybe choose to write it in terms of, let's see, I would start at maybe 11,000 going up. So it would be 11,000, maybe 11,500, 12,000, 12,500. So I'd use that type of scale. Why am I using that type of scale? Because already I can see I've got numbers that are in between, like that, 12,500 going on over there. And I've got more than enough space to draw this graph. So sometimes people are in such a hurry that they don't want to be putting down the correct things, okay? So what am I going to do? I'm going to start it from 11,000. I want to start it from 11,000. So I'm going to say, but what I can say is that it's number of fatalities in thousands. So I can write there a young 1,000. I'm just going to remove that. Thousands. And why am I saying that? So the person who's marking knows what I am talking about. Okay? So if it's in thousands, I can simply just say 11, 11.5. Let's make that a bit smaller. Do you see all the things that I'm doing? Trial and error. 11, 11.5, 12,000, 12,000.5, 13,000, 13,000.5, 14,000, 14,000.5. Where does it end? It ends at 14,000. So that is what we can work with. Okay? And because it ends at 14,000, then I'm not going to carry on in terms of those numbers over there. Now I'm going to draw. I'm going to use a lighter color so that it's not too much of a mess. So for 2012, we are sitting on 13,528. So I know we're sitting just above 12.5. So I can take my graph up. It's not going to be too accurate in terms of the ruler. But you get the idea. 2013, that is a rough draft. 2013, 11,844. So we know 11,844 would fall somewhere over there. Okay? So I'm going to take it up to there. Give yourself enough allowance to be able to draw your graph. Don't bunch your numbers all in one place, because sometimes learners want to bunch everything up in one place. This scale could have also been taken all the way up. I just chose to do it like that. 2014 is going to be 12,702. 12,702 would fall somewhere over let's see, 12,000. Okay, I'm going to choose that over there, somewhere over there. Nice one. 2015, these are all marks that I'm getting. 12,944. So it would be very close to that 13, but it's not touching the 13. So I'm going to do that. Okay. 2016 is the last one. 14,071. 14,071. So that one would be very close to the 14,000. So it's sitting somewhere there. And that's basically what is required of you when you are drawing a bar graph. Let's go to the next question. The next question that we have is from Lorinda. Okay, Laura, thank you so much for this question that you have given us. The question is a tank. It's on volume. Measurement. Thank you for this question, because measurement is that scary thing that no one really wants to do. But as soon as you start grasping it, because you are always given formulas, so you don't really want to run away from it. Catch your marks and run with them. So it says here, if the volume of the tank is 1,000 liters. So we've already been given the volume, which is that 1,000 liters over there. And the height is 130 centimeters. What is the diameter of the tank? So we've got over here, we've been given that 13 centimeters, which is the height, okay? 13 centimeters. That's the height that we have been given. So we want to know what the diameter is going to be. That is very, very important for us to know how to use it. And it says to us, round your answer to 2 decimal places. use the following formula that has been given to you. So now, in order for us to do a question like this, it's important for there to also be some sort of scale that says to us that 13 centimeters needs to be in meters or whatever the case is. But we're going to use that 130 as it is in those centimeters, okay? So let's see. If we were given anything else, we would use it the way that we are given. Please be careful in terms of that. So we've been given a nice formula over there, which is why I'm saying, guys, use this, okay? And then we have also been given our pi. If you've been given a pi, guys, it's important for you to use the pi that you have been given. Don't go and use your own pi, because pi can come in different numbers. Pi can be 3,14, pi can be 3, whatever the case is. So be careful in terms of that. And if pi is not being given, use the one on your calculator. But in most cases, pi will be given to you. So thank you for that question, Laura. It's 2.6. I hope you are watching. Volume is equal to pi times r square times height. Okay? So we have to manipulate this formula, but in order for us to find the diameter, we need to know the relationship between diameter and radius. I'm just going to put a little note on the side there. If we have our circle over there, we know that from the center to the circumference, that is radius. But what we need to know as well is the relationship between radius and diameter. And the relationship between radius and diameter is that the radius is half of the diameter. So from here to there is then going to be our diameter. So radius, so diameter is equals to radius times 2. So whatever radius we find, we're going to multiply by 2. We know our volume is 1,000. We know that. We know that pi is 3,142. We don't have our radius. That's what we're trying to figure out. And we have our 130 centimeters. I'm not going to write the centimeter out over there. Perfect. Let's manipulate our formula. Not too much of a problem, I hope, for you guys, because sometimes people get so scared when we need to manipulate. What are we going to do in order to eliminate these two numbers over here? Because we are working with multiplication, we are going to divide with those two numbers. So look at what I'm doing. Pay careful attention in terms of what I am doing. I'm going to divide both sides by those two numbers. So what am I dividing it by? I'm going to divide this side by 3,142 times 130, and I'm going to divide this side by 3,142 times 130. What is it doing? It's automatically removing those two numbers over there, and it's leaving us with the radius that we are looking for. Okay, let's go put that in our calculator. So that's 1,000. 1, 2, 3. Divided, I'll put those in brackets, 3,1, delete, 142 times 130, that's our height. And the answer is going to give us, I'm going to round that off to 2 decimal places because, wow, 2,45. 2,45, and then now I'm left with the radius square. Now I need to eliminate the square over here. And in order for me to eliminate that square, I need to put a square root on both sides. So I need to square root both sides. Okay? And let me just remove that little thing over there. Nice one. Me square rooting both sides then removes that square over there. Let's go put that in our calculator. Square root 2,45. So that then gives us 1,57, which is our radius. Now remember what I said to you guys. What is the relationship between radius and diameter? We are not done. We are not done. We are looking for the diameter. The relationship between radius and diameter is over there. In order for us to find our diameter, we need to multiply the radius by 2. So therefore, diameter is equal to 1, let's just clear that mess. 1,57 times 2. Careful, ne? So 1,57 times 2, 3,14. That's very interesting because it's like the pi, right? 3,14. Okay, so now we've got that. That, guys, then becomes our diameter. We found what we were looking for. That is going to be our diameter. So our diameter is going to be 3,14. And that 3,14 has to be in whatever that they have given us over there, which is going to be in centimeters. So it's going to be double of that. Okay, perfect. Thank you very much for that particular question. But it's not done. Let's go see what the second one says. It says, Ted keeps the tank at 2/3 of its capacity. So here it says that Ted keeps the tank at 2/3 of its capacity. How much water is in the tank? Round off to the nearest liter. Nice one. So now we know that Ted is keeping this tank at 2/3 of its capacity. 2/3 looks like this. 2.7. 2/3 is 2/3. Okay? That's 2/3 of its capacity. But what is its capacity? Of represents multiplication of 1,000 liters. And before we carry on, I need to caution you guys in terms of this. And the caution in terms of that is that Laura's question didn't tell us the relationship between liters and centimeters in terms of that. So that's why our answer is looking a bit shady. So be careful in terms of that. There should be a little scale that we have been given that says to us, listen, this is the relationship between the two things. Okay? So be careful in terms of that when you come to that as well. Carrying on. We are looking for 2/3 of 1,000. 2/3 of 1,000, we know that we're multiplying those two numbers. So it means that the tank is not full. Ne? It's not like full. Because if it was full, it would be 3/3. So 1,000 times 2/3. That's going to probably give us, there we go. I'm going to round that off to 2 decimal places. 666.67. 2/3 times. I'm just going to make that a little formal for you guys. 666.67 liters. If you don't have that liter, guys, you will not get your mark. Thank you, Laura, for that question.